Okay, we're finally to the point in this unit where we want to be able to solve for an exponent by using logarithms. At the very beginning of the unit, I said that was really what logarithms were invented for, to be able to solve for an exponent. Okay, so if we have 2 to the power of x equals 16, we automatically know here that x is equal to 4. And the reason we know that is because if we make the bases the same, we could represent 16 as 2 to the power of 4. And now since the bases are the same, those two exponents must be equal. Okay, the only way for that equal sign to be true is if, and the bases are the same, is if those exponents are equal. So then we can just say, okay, x is equal to 4. Okay, so then how do we solve something 2 to the power of x equals 10? That's what we're going to use logarithms for. But let's back up to another recall for a moment and think about solving for x here. 3x subtract 1 equals 5. The first thing we do is add 1 to both sides of the equation. What we do to one side of the equation, we also do to the other side of the equation. Okay, so then we get 3x equals 6. Now to get x by itself, or isolate x, we divide both sides by 3. What we do to one side of the equation, we also do to the other. And we get x is equal to 2. Okay, so the whole point here is if we do something to one side of the equation, we also have to do it to the other. All right, so let's solve 2 to the power of x equals 10. We're actually going to have 2 ways of doing this. All right, so method 1. Method 1, rearrange into a logarithmic statement. And remember, this is one of our tools that we have. Okay, we had 6 tools altogether to deal with logarithms, and change a base made 7. Okay, so here's one of our tools, rearrange from an exponent statement into a log statement. So let's do that. Log base 2 of 10 is equal to x. Okay, now if this was a non-calculator question, you could leave it like this. Okay, that would be a fair answer. If it's a calculator question, you probably want to find out what is that number equal to. So let's plug that in. If your calculator shows you, you can put bases in there, then you can do that. If your calculator doesn't allow bases, we can use the change of base rule to say log 10 divided by log 2. All right, and we get 3.32 approximately. So 3 significant figures. Okay. Method 2 involves what we do to one side of the equation, we also have to do to the other side. We're going to log both sides of the equation. All right, log both sides of the equation. So we start here, 2 to the power of x equals 10. Log both sides of the equation. Log of 2 to the power of x equals log 10. Okay, now because I didn't specify a base here, we're automatically dealing in base 10. Now using law number 3, we can bring the x, that exponent x, down as a coefficient in front of the log. And now to isolate x, to get x by itself, we can divide both sides of the equation by log 2. Okay, if this was a non-calculator question, we're going to want to take one step further. I'll show you in a moment. If it's a calculator question, you can now plug that into your calculator, log 10 divided by log 2, and you'll get the exact same answer as over here. Okay, however, if this is a non-calculator question, you should be able to notice here that log 10 is a special number. It's one of those counting by logs numbers. Okay, so let's think about this for a moment. Log 10 is actually log base 10 of 10 to the power of 1, and that's actually equal to 1. Okay, so we're thinking about this. So if this is a non-calculator question, you want to be able to simplify this a little further. X equals 1 over log 2 in this case. So non-calculator question, if you use method 1, this is a fine answer. If you use method 2, this is a fine answer. They are the same number as each other. You might get away with this as a final answer, but this is better simplified into this. There we have it, the whole reason we've been studying logarithms.